Hi everyone, welcome to another episode of ABAP Explained. In this video I would like to show you how you can upload some files, TXT or CSV, to your report and use the data that's inside of it to do calculations, fill in some database tables, and so on. For this one we just have a simple selection screen, file name is Separator, and when we click on the search herb for the file name, it allows us to browse our computer and select some files. So I'm gonna select the semi, and the separator is a semicolon. And when I run the program, I will allow to access the file. And as you can see, I have the simple display with the data that was inside of the file, separated in columns. To speed things up, I have created this report, ZMS upload files, which is an executable program. And I have added the selection screen with two parameters, one being the file name and the other one being the separator. And when we run the program now, you can see two things are missing. The technical names are displayed. We want to make it easier for the user, so we want to change that. And the second thing is that we don't have the search herb for our file name. It would be pretty hard to select it to pass the whole path with our keyboard or ourselves. So we're gonna change these two things. So first, go to text elements, selection text, and here you can change the display names of the variables, save and activate. So that's the first thing. Now it's pretty nice. For the other thing, it's gonna be a little bit harder. We need to do some coding. So to start with, we want to add this search help button. So to do this, we have to do add selection screen on value request for the variable, the parameter pfname. So when you click this, do something. Basically, that's what it states. We're gonna call a method and we'll use the standard class cell GUI frontend services. We'll be using this one later on also. And for this one, we have this nice method file open dialog, which is gonna, basically allow us to select a file from our PC. We have many parameters here, many attributes. We don't have to use all of them. Multi-selection is probably the most useful one, but for this one I'm gonna just do a normal selection, so we won't be selecting more files. You could do this, then loop around your files and read the data. And two parameters were stayed uncommented, so it means they're obligatory and you have to fill them up. So these two we can get rid also, and the exceptions we want to leave, of course, but still we won't do any or we will do one error handling, but we won't give any messages, any sort of these things. We just want to return to the main screen. So when you pass something that's wrong, or if something with the method fails, just gonna go back. These two parameters, we have to create variables for them. So the first one will be a local table LT files of the file table, if I recall correctly, and the other one return code of type integer. So it's more like sys over C. Let's pass them to our method LT files and LV return code. I'm gonna delete this text, do some formatting, and let's activate it. That's good. And now you can see we have this box, and when you click it, it will allow us to select any file from our PC. So for example, when I select this, and you can see, hey, it's not displaying, what's wrong? And the thing is, it's held in this file table, so it's inside LT files. You're not gonna see it on the P file name. It would be nice to do it automatically, but it's not doing it. So we have to pass the value from this table to this variable, to this parameter, so it will be displayed. And the user will know that he selected the correct file. So to pass this variable that's held in this file table, let's do pfname, and let's assign the first record that it holds. So we're gonna do this brackets and one, just select the first record, the record with the index number 1. And this would already work. One thing that we should always do is handle the exception that this table might be empty. You never know what can happen. You don't wanna, the last thing you wanna have in your program is a dump. So we're gonna catch this see it up line not found exception, and also do nothing, but it's enough to just catch it. Yeah, so we catch it. If it's something gonna be wrong, it's gonna return and do nothing. And now when we activate and run the program, and we can select a file, and you can see the whole path is shown, and we can add a parameter also. And that's the first part. One more thing I would like to do is to filter the file types that we are passing. The first idea was to trim the file type from the file name using the LT files table and some function model, but it seems there's a better way to do it, and we can pass the file types, accessible file types, directly into file open dialog. So now if we run our program, we can see it will select all files. Additionally, it will give us some more file types that are passed through the function model. So if we want to filter this, there's an exporting parameter, file filter. It's got this pretty weird syntax, but still it's not so hard to do. So first we give the description that is displayed in the window, and after you give the stripe and the file types after a semicolon that you are allowing to pass with this filter. So after doing that, if I activate and I click, you can see that that's my description that's showing, and it will allow to give me only these two file types to process, not more. So we had earlier we had this one access file, and now it's just only this 4. Next, we need to add the start of selection event. After that, we're gonna use a standard method from the class GUI front services also, and GUI upload. That's a pretty common one. Most of these parameters we won't use, so we can delete them. Actually, the only one I'm gonna leave behind is the file name. The other ones are useful, but in my case, I'm just gonna do this simple, a simple case, so we don't make things harder. And here we just need to give the file name, so pf name that we've passed before, and as data tab we need to pass here a table of strings, so lt file lines, and let's declare it file lines type table of string. Yeah, and let's activate that, and let's see how this looks like. Semicolon separated. It has these 4 lines red, but you can see it's with semicolon, and the semicolon information is for us that we pass in the selection screen, how we can process this data further. I'm also gonna give a message from a message class that I created before, just so we know if something goes wrong, and that the user can see that. It's gonna be message number 0 with the class ZCL error messages, where I can give a parameter. In this case, I'm gonna give the whole class and method name. Just like that, activate it. Let's just see in the message class, you can see I can give here one parameter, so error while calling this particular method. Now we're gonna have this data, and we are a step further. Having those lines read, we can start to split it into individual components. So to do that, we can do a loop on our table, and let's assign it to a field symbol. Let's say file line. And we're gonna use the split keyword to split it at the separator that we given on our selection screen. So basically, it's gonna be sep. And we're gonna fill an internal table with that. So let's say LT line split. For that, we're gonna need to declare a variable. Let's duplicate this. Additionally, I'm gonna create two more. One will be the structure of sFlight. Basically, we need this to describe the structure, so we can get every name of this table, every name of a field of this table. And we're gonna do one more of a table type. sFlight. Now let's see how this looks like. I just want to show you how this works, so you can get a better understanding. And this is the table, so you have every component in its own line. And now we just have to find a way to fill an internal table with that, of this sFlight type. So let's gonna do 4 times. Now we can use a standard class CL ABAP struct descriptor, I would say, because it's not stating the full name, to get the description of our structure that we want. So here what's needed, we need to do a downcast operator. And as I said, we're going to use this standard class, CL ABAP struct descriptor, and the static method describe by data. And what data do you want to describe? It's going to be the ls sFlight. So this can give us a lot of information about the structure, data types, descriptions, and so on. So that's pretty useful. And to do that, we're gonna of course need to declare this object, and that's gonna be a reference to the data it's gonna give us back. And since this is the downcasting operator, we could go here and see that it's returning operator attribute. It's CL ABAP type descriptor, but we're gonna actually need to declare it as not as this one, but since, as I said, since it's the downcasting operator, we're gonna need to use this one. So let's do that. Type reference to CL ABAP struct descriptor. And this should work, but that's not the only thing that we need to do. Now we have an object that's holding this whole data, or we have a reference to this data. Now we're gonna need to create another variable that's gonna hold the exact names of our structure that you want to see, which in this case is sFlight. So let's say LD structure component, and we're gonna address this structure, object, and we're gonna use the method get components. And that's like this what we need. Now activating that, I would like to show you how this works again. And here you can see, now it's initial, but if we go one step further, there's a lot of information that you can get. And here in the components tab is basically the names of the fields that we need. And using this method, we can just get this table right here with a lot more information. This is like another step below, another downcast to the element description. So it's gonna describe the mandate and so on. But for now, that's gonna be enough for us. And this is the old syntax you can do it in. If you would Google for this class, you would probably see this syntax. But we can do one better. I'm gonna use this inline declaration here also and use the cast operator. So it's gonna do the same thing as we saw here, but I'm gonna do it in one line without predefining this object. So I'm gonna cast to this type, and here I'm gonna do the same thing inside. So I want to return this type, do a cast, downcast to this type, and then I'm gonna chain this method also. So I will get these components. Yeah, as I said, basically doing the same thing without declaring this. And if we activate, the effect is gonna be the same. Now we can go through these components by doing another loop. And let's call it component. And to build the structure LSS flight, we're gonna need to have the names of the fields. So to do that, I'm gonna declare another variable LV field name, and we're gonna access those names by index using setabix, and I'm gonna read the column name. So here will be the current name, and now we can use the assign component, or basically the assign keyword, and assign the field of this name of structure as sflight to a field symbol. Let's call it field to fill. So this is a reference to a field of this name of the structure as flight. And the last thing to do is just to fill this value with the value from the file. And that's actually it. I'm gonna show you now in the debug how this works, so we'll get a better understanding of that. Make this a bit wider. Okay, so we are going through every component, which variable is stored in the component field symbol. Then in the field name, you're going through the LT structure component table. Here's the column name, and we're getting those by the index. And we are assigning the mandate of the structure LSS flight to this field symbol. So this is our reference to the field mandate of the structure LSS flight, holding this value, and we are filling it with the value from this current line, from the line of the file, and this will be filled. So at the end, we're gonna have a structure that's gonna be filled one by one. I'm kinda spamming now, and you see at the end we're gonna have a filled structure. Okay, so now the last thing that we just need to do is to take this structure and append it to a table. So we're gonna assign to LT flight, and now we can take this table and display it simply using the standard class CLDemo output and the static method display. Just passing inside our table. Let's activate and see the result. As you can see, the data is nicely displayed. And let's test some more test cases. So I've got some more files prepared, which will be this comma separated file, semicolon separated file, but it's a CSV. And the last one would be a tabulator separated, which would be an interesting case that we will need to do some corrections in our program for that to work. But for now, let's test these two. So we take this comma separated. It's working fine. Maybe the conversion for this date is somewhat wrong, so we could do some correction there, but for now let's leave it. And the CSV, it's a semicolon separated. As you can see, everything is filled fine. Now the interesting thing for the tabulator separated is that the GUI upload, without specifying any additional parameters, is gonna convert every tabulator to a hash in our lines here in this table. So to change that, you could say easily, okay, let's just give on the selection screen the separator as a hash. But the hash that we give from our keyboard is different than the converted one in the program. So to visualize that, I will do some constants. So the first one will be C hash, which would be the default one that we give on that we type. And the second one I would call CTab. It's gonna be also a C, and the value is gonna be some constant from this standard class, so horizontal tab. And for this to work, we need to do something like that. So when someone gives as the separator the hash value, we need to change it to this constant because it's different. And if we would use the split command, it wouldn't recognize that this hash that we give from our keyboard is the same that the converted one and those splitted lines is. So I'm gonna do this, activate it, and here let's see the difference. So I'm gonna take this tabulator separated, give on the hash, and if we see on those two constants, you can see that the hexadecimal value is different. So when we do the comparison or doing the split, it's looking not for this one, 0900 is looking for the, or rather it's looking for the 2300 that we give on the selection screen, and it's finding only this one, and it's not changing this. So we need to change this separator to this 0900. So now when we split it, it should identify it and it should convert it normally. So when we read this file, we've got those hashes, and those hashes are the 0900, not the 2300 that we given from our keyboard. And as you can see, it's converted nicely. So I hope you understood that. If you've got any questions or suggestions how we can do it better, I'd love to see them in the comments. So thanks for watching. Leave a like, a subscription, and see you next time.